I have a system. This is again a quadratic system. I have x and y. This one, since the y is linear, it will be much easier to substitute for the y or subtract for the y. This one again, if we had tried to get rid of the x and x squared, that's very difficult. But this one, because the coefficient, the proportion, and the signs of the coefficients are actually in proportion, it is actually possible, but this is not the recommended strategy. So I'm just going to go ahead and solve for y here. So I'm going to take this equation. So I'm going to end up with negative 5x. In fact, I think I'm just going to subtract these because these ones look a little bit, because the coefficient is 1 here, I'm going to multiply this by 3 and subtract it. So I'm going to do 3 times equation 2. And I end up with 15x squared minus 30x plus 3y plus 6 equals 0. And I'm going to subtract those two equations, and what will end up happening is I end up with the 3y's canceling out. So I end up with negative 14x squared plus 28x minus 6 equals 8. So, yeah, that looks right. So it looks like I have a common factor of 14. So I'm just going to, first of all, get all my like terms together. I'm going to divide both sides by negative 14. So I'm going to end up with x squared minus 2x plus 1 equals 0. And factor and solve. This one happens to be a perfect square, so I'm just going to solve it as x equals 1. There's my solution for x. I do want to solve for y. Okay, so this is going to plug into here and here. And you could have plugged it into the other equation. In fact, it does look like it's slightly easier to plug it into the other equation. But once I plug it in, again, I now have an equation with only one variable, which I can solve for. So I'm going to end up with negative 5 minus 10 is negative 5, plus y plus 2 equals 0. I'm going to add 3 to both sides, and I end up with y equals 3. So it looks like I just have one solution for x and one solution for y. The quadratic does give me a single solution, which means that and this is hard to predict, but this probably means that the solutions meet at the vertex. Okay, and so we end up with this, the graph of this, and we can again go ahead and graph this on Desmos. The solution will meet at the vertex. And again, it's a very good idea to graph these to just check your answers. Okay, so if you don't have a solution, on your answer keys, just go ahead and graph this. It's really important to have a sense of what these graphs look like. So again, here we have a quadratic system. In this case here, it looks like we can maybe solve for one of the variables, a squared or b. Since there's no a and a squared, let's go ahead and see if we can solve this by getting rid of the a. So first thing I'm going to do actually is I notice that these both have common factors. So I'm going to divide everything by 2. So I'm going to end up with 2a squared 4b minus 3 equals 0. Divide everything here by 3. So I end up with 2a minus 3 minus 4b equals 0. Okay. So when I do this, look what happens. So I'm going to just subtract these two equations. And when I subtract these two equations, well, in fact, they're the same equation. So I'm going to subtract one as 2a minus 3 minus 4b equals 0. I end up with 0 equals 0. Okay, so just highlight this here. This equation here is this one, but it happens to be the same as the first one. So what happens? What does this mean? Well, this means that we have the solutions are going to be for A or B, if we think of independently, are going to be all real numbers. Now imagine what the two graphs would look like. Okay, so I'm going to end up with two graphs here. So remember that the solution is in two-dimensional space. So we're just going to say A is all real. Now, it doesn't necessarily pair with B is all real, but independently B could be all real numbers too. So what we would end up having is, and we should actually graph this, but imagine what we have. We have two parabolas, and they're basically on top of each other. Well, that means that we have A and B are all real numbers. Here we have the solutions for A and B. However, the solutions are going to be based on these two graphs, these two lines. So although we can say A is all real numbers, really the solution actually is going to look like this. The solution is the actual equation, is A squared minus 3 minus 4B equals 0. This is my solution. Okay, so this is how I express it. And this is ones where, just like in when we had linear systems, the solution was consistent, okay, and infinite. Okay, this is what the terminology we use in grade 10. So this solution is consistent because it is consistent, 0 equals 0, and it's infinite because there's infinite possibilities that solve this equation. And the actual solution is we show as the actual equation of that graph. Okay, so if I were to graph this again, this graph would be just two graphs here. Actually, technically it would look like this. Okay, and we would have one graph that looks like that, and we'd have a second graph that just overlaps that first graph. So the solution is all real, is going to be infinite. We have infinite solutions. Okay, so we have infinite solutions here. Okay, and then this one here, let's take a look at this. We have A squared, B squared, A. So it is difficult to get rid of A and A squared at the same time. Here we only have one B squared, so we really, when we analyze this, the way to get rid of the variable is, the variable that's going to be easier to get rid of is going to be the B squared. So I'm going to add 2 to both sides, and I now have a B squared. And I'm going to use substitution. So I have a like for like here. These are equivalent to each other, and I'm going to do like for like substitution. And by doing so, I'm going to be able to eliminate the B variable. Now that would have been very difficult to do with the A and the A squared, but since we have a B squared here, only a B squared and only a B squared here, that would be the easier choice to do the substitution. So I'm going to substitute an equivalent for B squared, which is 2 plus 2A minus A squared, and then minus A equals 4. So here I've done, again, my like for like substitution, like for like replacement. And going ahead and solving this, A squared minus A squared cancel out. 2, so I'm going to end up with 2A minus A is plus 1A. Equals 4. Solving for A, I get A equals 2. Okay, so if A equals 2, looks like I'm going to have a quadratic solution for B, so I'm going to plug that back in. Since it's equal to B squared here, I'm just going to plug it into there, so I end up with B squared equals 2 plus 2 times A minus A squared. B squared is equal to 2 plus 4, 6, minus 4 is 2. So B is equal to plus minus root 2. So my solutions are going to be A equals 2, B equals root 2. a equals 2, b equals negative root 2. Remember that they come in pairs. These solutions come in a and b pairs. It's a quadratic system, and we end up with two solutions.